most of human history, space and time felt like the most basic ingredients of reality. Everything existed somewhere. Everything happened sometime. Distance separated events. Time ordered them. This framework felt so obvious that no one questioned it. Space was the stage. Time was the clock. Reality unfolded inside both. But modern science has uncovered something deeply disturbing. Space and time are not fundamental. They are not the base layer of reality. They are emergent. They rise from something deeper. And once this realization is understood, the universe stops looking like a place and starts behaving like a process. At first, this idea sounds impossible. How can space not exist? How can time not flow? Everything we experience depends on them. But history shows that reality has betrayed intuition before. The Earth felt stationary. It was not. Matter felt solid. It is mostly empty space. Cause and effect felt absolute. At the deepest levels, it begins to blur. The idea that space and time might be illusions is not philosophy. It is the result of decades of experiments, equations, and contradictions that refuse to disappear. The first cracks appeared when scientists tried to unite the two greatest frameworks ever built to describe nature. One governs the very large stars, planets, galaxies, gravity itself. The other governs the very small particles, fields, probabilities, uncertainty. Each works perfectly on its own. Together, they refuse to cooperate. When forced into the same equation, space and time stop behaving. In some cases, time disappears entirely. In others, space breaks into discrete pieces. In others still, neither concept survives at all. One of the strangest discoveries was that when systems are examined at the smallest possible scales, distance loses meaning. Particles separated by vast space behave as if they are part of a single object. There is no signal traveling between them. No delay, no medium. The connection is immediate. This is not faster than light communication. It is something more unsettling. It is as if space is not what connects things. It is something that emerges after the fact. As experiments became more precise, scientists noticed something else. Information appears to be more fundamental than location. Systems that share information behave as a unit, regardless of how far apart they are in space. This suggests that space is not the container of reality, but a byproduct of relationships between things. In this view, the universe is not built from objects sitting in space. It is built from connections. Space is what those connections look like when viewed from the inside. Time fared no better. At the deepest levels of physical law, time often fails to appear at all. Equations that successfully describe the universe do not require it. They work without a flowing present, without a ticking clock, without a before and after. This raises an unsettling possibility. Time may not be something the universe uses. It may be something the human brain constructs. Clocks do not measure time itself. They measure change. When nothing changes, time becomes meaningless. At the most fundamental level, reality may be a static structure, not frozen in the sense of motionless, but complete. All configurations exist. What we experience as the passage of time may simply be the way consciousness moves through this structure, stitching moments together into a story. This idea is uncomfortable because it removes a privilege humans assume they had. We believe we live in the present, moving forward into the future. But if time is emergent, then the present is not universal. Different observers experience different sequences. There is no single now, no master clock, no cosmic moment shared by everything. The universe does not update itself. It simply is. As scientists explored these implications, a new picture began to form. Reality at its core may be mathematical, not numbers on paper, but abstract relationships that give rise to everything else. Space emerges when relationships are arranged in certain ways. Time emerges when systems change relative to one another. Matter emerges as stable patterns within this structure. Even causality may be approximate, not fundamental. This framework explains something that once seemed mysterious. Why the universe appears fine-tuned. Why physical laws are precise. Why reality is describable at all. If the universe is not a collection of objects, but a self-consistent structure, then only stable configurations can exist. Everything else simply does not appear. It also explains why attempts to find the smallest building blocks keep failing. Every time scientists think they have reached the bottom, something deeper appears. Smaller scales reveal non-objects, but interactions. Not particles, but probabilities. Not space, but networks. Reality refuses to be reduced to pieces because it was never made of pieces in the first place. This view changes the meaning of observation. Observers are not external. They are part of the system. When something is observed, It is not being revealed. It is being selected. Out of many possible states, one becomes real relative to the observer. Reality does not collapse into existence. It aligns. This has profound consequences. If space and time are emergent, then distance is not absolute. Duration is not universal. The universe is not a place where things happen. It is a structure where relationships exist. Movement through space is not fundamental. Movement through time is not fundamental. Change itself may be secondary. Even gravity, once thought to be a force, now appears to emerge from information. When information is arranged unevenly, what we experience as gravity appears. Objects fall not because space pulls them, but because systems evolve toward configurations of maximal consistency. What feels like attraction may be geometry reshaping itself. This idea feels abstract, but it produces real predictions. It explains why black holes behave the way they do, why information is never truly destroyed, why the universe resists being divided cleanly. It also suggests that reality has limits not because of physical barriers, but because of logical consistency. Some things are impossible not because of energy or distance, but because they cannot fit within the underlying structure. As unsettling as this sounds, it offers a strange comfort. If space and time are emergent, then the universe is not fragile. It is not balancing on delicate constants. It is stable by necessity. The reality we experience is not random. It is inevitable given the structure beneath it. Yet this understanding comes at a cost. It removes the comforting illusion that we are moving through a simple world. It suggests that what we call reality is more like a projection, a user interface, a simplified view that allows consciousness to function. Just as icons on a screen are not the files themselves, space and time may not be reality itself, but a representation. This does not make the universe less real. It makes it stranger. It means that beneath every moment lies a deeper order, inaccessible to intuition, a precise beyond imagination, an order where space dissolves, time fades, and only structure remains. The discovery that space and time are not fundamental did not arrive with an announcement. It emerged quietly, through contradictions that refused to vanish, through equations that worked too well, through experiments that behaved perfectly. Science did not decide to abandon space and time. Space and time simply stopped appearing at the deepest levels. And so humanity now stands in an unfamiliar position, living inside constructs that feel absolute, knowing they are not, experiencing moments that feel fleeting, knowing they may all coexist, measuring distances that feel real, knowing they may be shadows of deeper connections. Reality has not changed, but our understanding of it has. And once you see space and time as emergent, it becomes impossible to unsee. Have you ever looked up at the night sky and felt a profound sense of wonder? A feeling that there's something more to reality than what we see? What if I told you that the solid world around you, the very fabric of space and the relentless march of time, might not be as fundamental as they seem? Today, we're diving deep down the rabbit hole to question everything we think we know about existence. Let's start with space. We experience it as this vast, three-dimensional container where everything happens. But what is it, really? For centuries, we thought of it like an empty stage, a backdrop for the cosmic play. Newton saw it as absolute, fixed, and unchanging. Then came Einstein, who completely flipped the script. He showed us that space isn't just an empty void. It's a dynamic entity, woven together with time into a single fabric, space-time. And this fabric can be bent, stretched, and warped by mass and energy. This is what we call gravity. The Earth isn't being pulled by the sun. It's following the curve in space-time that the sun creates. But the story doesn't end there. Quantum mechanics, our best theory of the very small, throws another wrench in the works. It suggests that at the most fundamental level, space might not be smooth and continuous at all. Instead, it could be made of tiny, indivisible units, like pixels on a screen. This is the idea behind theories like loop quantum gravity. Imagine zooming in on a digital photo. At first, it looks smooth, but as you get closer, you see the individual pixels. What if our universe is like that? If you could zoom into the smallest possible scale, the Planck length, you might find that space itself is granular, discrete. This would mean that the concept of location breaks down. There's no in between 2 points. It's a staggering thought. Even more mind-bending is the holographic principle. It suggests that all the information contained within a volume of space, like this room or even the entire universe, can be described by a theory living on the boundary of that space. It's like a hologram. The three-dimensional image you see is encoded on a two-dimensional surface, Could our 3D universe be a holographic projection of information stored on a distant 2D boundary? This isn't just sci-fi speculation, it's a serious idea born from the study of black holes. It challenges our most basic intuition that we live in a three-dimensional world. It suggests that space, as we perceive it, might be an emergent property, not a fundamental one. Now, let's talk about time. We experience it as a river flowing from the past, through the present, and into the future. But physics tells a different story. In Einstein's relativity, there is no universal now. The present moment is relative to the observer. Your now is different from the now of someone moving at a high speed relative to you. This leads to the block universe model, where the past, present, and future all exist simultaneously. Time doesn't flow. It's just another dimension, like the dimensions of space. We just happen to be experiencing it slice by slice. The feeling of the passage of time, that forward momentum, might just be a trick of our perception, a feature of our human consciousness. But if the future already exists, what does that mean for free will? And why do we remember the past, but not the future? This is the puzzle of the arrow of time. The laws of physics, for the most part, work just as well forwards as they do backwards. A video of planets orbiting a star would look perfectly normal if you played it in reverse. Yet, in our macroscopic world, time clearly has a direction. Eggs break. They don't unbreak. Ice melts. It doesn't spontaneously form from a puddle. This directionality is linked to entropy, the tendency for systems to become more disordered over time. The universe started in a very low entropy, highly ordered state at the Big Bang, and it has been getting more disordered ever since. Our perception of time's arrow might simply be our experience of this inexorable increase in entropy. So, we have space that might be an illusion, a hologram, and time that might be a static dimension our minds perceive as flowing. What's left? What is the bedrock of reality? This is where the most mysterious and intimate part of the puzzle comes in, consciousness. For a long time, science treated consciousness as a mere byproduct of the brain, a ghost in the machine. The prevailing view was materialism. Everything, including our thoughts and feelings, is ultimately just the physical interaction of particles. Your sense of self, your love for your family, the experience of seeing the color red, it's all just complex brain chemistry. But this view has a huge problem, often called the hard problem of consciousness. How does inert, unthinking matter give rise to subjective, first-person experience? How do electrical signals in the brain become the feeling of joy or the sting of sadness? This has led some physicists and philosophers to consider a radical alternative. What if consciousness isn't a byproduct of the physical world, but is actually fundamental to it? This idea, known as panpsychism or idealism, proposes that consciousness, in some rudimentary form, is a basic property of the universe, just like mass or charge. Perhaps every particle has some tiny, primitive glimmer of experience, and when these particles combine in a complex structure like a brain, a higher level, more complex consciousness emerges. This might sound far-fetched, but it's an idea that resonates with some interpretations of quantum mechanics. In the early days of quantum theory, physicists were baffled by the role of the observer. A quantum system, like an electron, can exist in multiple states at once, a superposition. It's only when we measure it, when we observe it, that it collapses into a single, definite state. This led some pioneers like John Wheeler to propose a participatory universe, one in which reality is brought into being through the act of observation. In his words, no phenomenon is a real phenomenon until it is an observed phenomenon. If this is true, it changes everything. It means we aren't just passive observers of a pre-existing reality. We are active participants in its creation. Our consciousness isn't just a late-coming accident in a dead universe. It's a fundamental part of the cosmic architecture. It suggests a deep connection between the inner world of our minds and the outer world of the cosmos. So, where does this leave us? We've journeyed from the fabric of space-time to the pixels of reality, from the block universe to the participatory universe. We've questioned space, time, and matter, and found that they might all be emergent phenomena secondary to something deeper. And that deeper something might just be information, or even consciousness itself. The truth is, nobody knows for sure. These are the biggest questions we can ask, and they're at the very frontier of science and philosophy. Let me know your thoughts in the comments below. Exploring these ideas together is what makes this journey so exciting. Thanks for watching, and if you enjoyed this deep dive, don't forget to like, subscribe, and hit that bell so you don't miss our next exploration into the mysteries of the universe. See you next time.